All right, this is a little extra practice for Algebra 1 working on factoring out the GCF. And so you can see the instructions here say to factor out the GCF, and we got this expression right here. A couple of brief background things. Let's keep in mind that because we've got 1, 2, 3 terms, this is a trinomial. And so we're going to work from that perspective, and we're going to try to factor out the GCF. So as I mentioned in class, this, what I'm about to show you, is kind of a slow way of doing this, but it's a really good way. It shows you what's actually happening and allows us to, for sure get the right answer. Eventually the hope is that we'd get a little bit faster than this, but this is a good place to start. So what we're going to do to begin with is we're going to find the prime factors within each of the terms. So for example, the 9 right here, the prime factors of 9 are 3 times 3. So I'm going to write that out as 3 times 3, and the prime factors of x squared would just be x times x, and then y is prime. There's only one of them. And then I'll proceed to do that same type of work with the other terms. So the next term we have plus 6 is 2 times 3, and let's try that again, 2 times 3. X is prime, y squared would just be y times y. And then the last term is already prime. 3 is a prime number. X, there's only a single factor there, and same with y. So what we're going to do now is we're going to go through and try to find out what's in common amongst all 3 terms. So I'm going to start off numerically. So I see that within the 3 terms, there is a 3, and a 3, and a 3. So all 3 of these terms, all of them, not just 2 of the 3, but all of them, have a common factor of 3. So that 3 is going to be part of my GCF. If we look really carefully, I don't think there are any other common numerical factors. This first term has a 3. This one doesn't. This one we already factored out the 3. We can see that 2 hanging out there with the middle term, but none of the other terms have a 2, and so that 3 is the only numerical factor. We're going to find that there are some other variable factors that are in common. So for example, this x is in common amongst all 3 terms. So because that x is common for all 3 terms, it'll be part of our GCF, our greatest common factor. And then lastly, we have a y. There's a y in all 3 terms as well, and so that's going to be part of my GCF also. So to finish this off, let's remember that factoring out the GCF is essentially just the reversing of the distributive property. And so as we try to write the leftovers from this process, we need to write the symbol that's always associated with the distributive property, and that is a parentheses. To finish this out, we simply need to notice what has not been highlighted, and that's what's going to be left over. So for example, in the first term, looking right here, the only 2 factors that have not been factored out are this 3 right here and this x right here. So for the first term, the leftovers would be 3 times x, or just 3x. For the second term, there are 2 factors that have not been factored out, the 2 and the y. And so I'm going to put plus, just continuing this plus sign on down. The remaining factors are 2y. And then the last term is being subtracted, so I'm going to put minus, and this one is perhaps the most tricky, but if we remember that factoring out the GCF is simply the reversing of the distributive property, maybe we can think about what this would be. Because if you look at this, it appears that the entire term has been factored out. And so you might be tempted just to write nothing right there, just a blank, or maybe a 0 or something like that. But let's remember that the distributive property is multiplication, and so the reversing of the distributive property would have to be division. So if I had a 3, an x, and a y, and I factored all of them out, what's left over is a 1. And so we can maybe see why that makes sense by checking this. And so I'm going to strongly encourage you to check these. We can check this by doing a distributive property. So if I multiply that 3xy back in, 3xy times 3x as I distribute there is going to be 9x squared y. And then as I distribute to the second term, 3xy times 2y is plus 6xy squared. And now maybe you can see where that 1 comes from. If that 1 wasn't there, when I tried to check this, then I wouldn't get that third term, and that third term was there, so it can't just disappear. And so as I distribute 3xy times minus 1, I get minus 3xy. So you can, of course, see that this is exactly the same as what we began with, and so I'd say that we're probably good. Keep in mind that this is the answer we're looking for right here. At that point right there, we have factored out the GCF. That's an answer. This down here is just a check. So, like I said before, I'm going to strongly encourage you to check, but this, I want to make sure it's clear that this up here above, that's your answer. Okay, check out the little question coming up next, and I'll see you in class.